Okay, today I'm talking about one of the CG lab programs, that is develop a menu driven program to fill the polygon using a scanline algorithm. So the main aim of the program is to fill the polygon area by using a solid color with the help of the scanline area filling algorithm. So before explaining the exact program, I would like to brief about scanline polygon fill algorithm. Let's see then. So scanline polygon fill algorithm. So this polygon fill algorithm is used for filling the solid color in the polygons. So the polygon is an ordered list of vertices as shown in the following figure, which means when we develop a polygon, so there is an ordered list of vertices should be present. So for filling the polygon with a particular colors, so you are here the main funda is to filling the polygon with the particular colors. So for that, what we need to do? So for that, we need to determine the pixels falling on the border of the polygon and those which falling inside the polygon. So firstly, we have to find out the pixels where it exactly present. So here to fill the polygon with a solid color, so firstly we need to determine the pixels where it's present the border of the polygon and some of the pixels which is present inside the polygon. So only take those particular pixel, then we need to fill the color in it. So there are some steps to be performed. So for scanline polygon filling scanline polygon filling, there are three steps to perform in the following order. The first one is find the intersection of the scanline with all the edges of the polygon. So with the first point, as you can come down and see the image over here. So what they're telling is find the intersection of the scanline with all the edges of the polygon. So here the polygon having edges, right? So also we passes the scanline so on the polygon. So here what is the point is to we have to find the intersection of the scan line as well as the edges. So the telling we have to find the intersection of the scan line and the edges of the polygon. So wherever the scan line passes, so that intersection that intersection with the edges of the polygon, that we need to find out. So with the figure we can easily find the intersection point of the edges of the polygon as well as the scan line should be presented should be represented by giving some values in it. So you can see here P0, P1, P2, P3. These are the intersection point of the scan line as well as the edge of the polygon. So next point is sort the intersection by increasing x coordinate, that is from the left to right. So once after we finding the intersection of the scanline and the edges of the polygon, so next thing is, so wherever the intersection which is present, we have to sort it in the increasing x coordinate, that should be follows the that should be follows from left to the right. Next, third one is make a pair of intersection and fill in color within all the pixels inside the pair. So once after we sort the intersection in the x coordinate from left to right, then the next thing is, so we have to pair it. So we have to pair the intersection points, so that is p0, p1, p2, p3, like that we have to keep it in a pair. And so wherever the the pairing intersection, wherever it presents, so only within that area we are going to fill the colors. So to make you understand in a better way, so here I explain the algorithm. So with respect to this figure, you can see this. So find out the y minimum and y maximum for the given polygon. So step 2 is scanline intersect with the edge of the polygon from the y minimum to y maximum. So name each intersection point of the polygon as per the figure shown below. There are named as a p0, p1, p2 and the p3. So next thing is sort the intersection point in the increasing order of the x coordinate. That is, see, we are sorting the intersection point. So P0, P1 is the one pair, P1, P2 is the another pair, and again P2, P3 is the one more pair. So fill those pairs of the coordinate that are inside the polygon, and we are ignoring the alternate pair, which means wherever the intersection point which is present inside the polygon, I mean intersection point with the scan line which is present inside the polygon, that we take it as in consideration, and the line with the intersection which is outside the polygon, we are just discarding it. So this is what the main idea of the scanline algorithm. And few concepts of the polygon filling. So here these concepts are kind of important. I'll just let you know what exactly the terms defining. So edge bucket, it contains an edge information. So this edge bucket contains an edge information means, so edges which are present to form an polygon. So those edge information, each and every edge information were present in the edge bucket. Like what is this edge information? Edge information nothing but the edges having how many vertices, what is the size of the edge, what is the color of the edge, what is the width, what is the height, so something like that. So it's contain all the information of the edges. So edge table, it consists of a several edges, holds all the edges that compose the figure. So here it is not about information, it just contain the edges, like how many edges present to form a polygon. So like that all the edges it going to be list and put it in a edge table. So on creating the edges, the vertices of the edge needed to be ordered from left to right. So when we listing the edges or to creating the edges, the vertices of the edges, which means points, the coordinate points of the edges need to be ordered from left to right, and the edges are maintained in increasing y-min order. So it should be keep it in an ordered way. So that should be ordered from left to right, and it started from the y minimum to y maximum. Filling is completely once all the edges are removed from the ET. So here we kept all the edges which is needed for creating the polygon, and it's only a information about edges, like how many edges should be needed for creating the polygon or like that. But once all the orders increasing, once all the order of the, I mean, once all the order of the points, and once all the order of the points that should be from increasing order. So once we keep it like this, and this is again our information which is taken to filling the polygon. So here we are not doing anything, we just remove all this thing, we just remove all this, remove nothing but we just taking all the information of the edges, and we just pushed it to into the active list. So when the edges, when it comes to the active list, then we can start filling the polygon coloring. So you can see here active list, it maintains the current edges being used to fill in the color. Yes, so it takes the edges list from the edge table, and it takes edges list from the edge table, and here in an active list, so it should be used it should be, I mean, the edges should be used to fill the polygon. Edges is all pushed into the AL from the edge table when the edges are y minimum equals to the current scan line being processed. So this active list will be resorted after every passes, so that this active list should be always repeated, so once after every passes. So now, okay, this figure, I mean this image, it's a kind of very important with respect to the programming. So as you can see the polygon that is quadrilateral. So here, as you can see the quadrilateral here, it is a scan line. So you can see the scan line, we have in many scan lines. Okay, so like 1 2 3 4, like that we have in many scan lines. These scan lines like this at every interval along with the y-axis. So like this it should be present at the every interval along the y-axis. Then you need to calculate. So once after writing the scan line like this, then you need to calculate the intersection point with this scan line. So there are some intersection point which is present on the polygon that is quadrilateral, that we have to calculate with the scan line only. So how we get the intersection points? So with the help of the scan line. So we have to calculate the intersection point with this scan line, whether the left edges as well as the right edges. So once the scan line which is passed over the polygon, so we will get the intersection point left side as well as the right side. So for each scan line that we need to calculate the left intersection point and the right intersection point. Once we get the intersection point, we need to fill all the pixels which is lies between the left intersection and the right intersection. This is the main idea of this programming. So now we will see the programming. Now we will see the programming. So the program polygon using scanline fill algorithm. So before yeah, these are the main library functions which we are included. So that is standard library, studio.h. Glad this should be must and should, otherwise. So I mean, like whatever the functions or the commands which we are using under the OpenGL, that will not work. And this floats or the what is this points, like for creating the quadrilateral polygon. So we have an four coordinates points. So that is why x1, x2, x3, x4, y1, y2 on the y3, y4. So that is why these are the points. Void edge detect. So what is this void edge detect? This is the yeah, this function void edge detect is a function. So this functions contain the coordinates of the edges and the address of the variable, that is LE and the RE. So the output of this function is to update the value of the X for left edge of the polygon and the right edge of the polygon. So to make it happen, to obtain this, first we need to find the first we need to find the First, we need to find the inverse of the slope. So here you can see, so mx denotes the inverse of the slope. So the output of this function is to update the value of the x for left edge of the polygon and the right edge of the polygon. So the process of this output is to find the inverse of the slope, and first thing is find the inverse of the slope, and then from starting from the lower integer value of y to the greater integer value of y. So complete the value of x for the left edge and the right edge, and update the value of x for the both the edges. Update the value of x for the both the edges. That is the function, that is edge detect, void edge detect. So here you can see, so the whole processing should be end up with the updation of x value. You want, I can repeat again. So this void edge detect, this function contain the coordinates. This functions contain the These functions contain the coordinates of the edges and address of the variable LE and RE. So the output of this function is to update the value of x for the left edge of the polygon and the right edge of the polygon. So to obtain this output, what I mean, some points to be follow. What are some points to be follow? That is, first one is find the inverse of the slope. Okay, find the inverse of the slope. Once again. Find the inverse of the slope, and that should be starting from the lower integer value of y to the greater integer value of x, and compute the value of x for lower edge and the lower compute the value of x for the left edge and the right edge, and update the value of x for the both the edges. So here we are going to update the x value. Can you see that the changes of 1 for the y causes the changes of the mx in the legs, like with the every inverse of the slope, whatever we're doing, so every inverse, so according to the y value, whenever the y value changes, the x value will also changes with the help of the slope function. So next thing is void drop pixels. So this void drop pixel, in this function what we are doing is, so they're given the coordinate points, that is x and the y. So we're just filling the color to the given coordinates. So void drop pixel in x and the y are the given coordinates, And with the color, can you see this 1.0, 0.0 and 0.0? So here they represent the 1.0, which means we're just going to take the red color to fill the given coordinates, and only they represent only 1 point. So that is why it's started from the GL begin function, so and end up with the GL end, and there's only, we are just representing only 1 point, so in the form of GL vertex 2I with the coordinates point x comma y. So next is the scan fill, void scan fill. So what is this void scan fill? In this function, the inputs are the vertices of the polygon and the output should be a filled polygon. So this is what the main idea of this function. So here they're given the inputs, that is vertices point, as you can see, float 1, float y, float x2, a2, like that. They're just given the vertices of the polygon. Now we fill the polygon by taking vertices of the polygon. We are just filling the color for the given polygon. So the scan line mainly used for filling polygon with a color. So initial array. So here in the program you can see there is an initial array LE, that is left edge, that should be 500, and right edge to the 0. Right edge to the 0 for the values of y, called function edge detect. So after we initializing the array, which is calling the edge detect, where you can see. So we're just calling the edge detect for the edges of the polygon one by one to set the values x for the each values of the y within that given line. So here the edge detect, which is calling the edge detect, so it happened filling the edges, calling the coordinate points, and also helps in setting the values for x coordinates as the y coordinates. So next thing is for the main function scan fill. The scan fill will just take the vertices points and just try to fill the color in it. Void display. Void display. So it is a callback function. Here it is globally defined vertices of the polygons are present, then it display the filled polygon. What this display will, void display will do means we're just giving the globally defined vertices of the polygon, so which means polygon edges. So then it display the fill polygon. So once after that it just display the fill polygon. So with the help of the line loop, so here you can see the function line loop. So with the help of this line loop, we can draw the polygon using the function scanline. We will fill the polygon with a solid color. So this line loop help in creating the quadrilateral with a closed, in the closed one. So just the function GL begin GL line means we're just going to create the line segment. If it is line loop means for the line loop we're going to draw in the loop formation. So that is what the GL begin line loop. And my init and void main, these are the main functions to define all the functions within it to execute the output. In the void my init, real color is including the windows, windows. So here point to all the 4 values should be 1.0, which means the backs, the display color, the output display color should be in the white and GL color. So this GL color 3F should be the, what is this, this function mainly used for giving color to the polygon, that is red color. Point size, whatever the edges we are going to use to create the quadrilateral polygon, so the point size should be 1.0. GL matrix mode. So GL matrix mode is a function for the projection of the output on the display. GL ortho 2D, so this is an orthogonal, this is an orthogonal projection. It's having some values in it. So according to the value only that should be displayed. So void my init. So this glut init, glut init to initialize the argument, glut init to initialize the given main function, so my init function. So then glut init display mode, it is a single and the RGB color. This is a single polygon, and with the using of RGB we are going to display the polygon. Window glut init window size, it is of 500 into 500. It just giving the size of the window, output window, it is of size 500 into 500. And the window's position, so with the size we also need to give the position of the window, like how much, I mean what is the size of the window to be displayed. So glut create window, we also giving the heading or the menu for the uh, given window, that is filling in polygon using scanline algorithm. I think you can know this because when displaying the images on the top of it, it's showing the wordings, I mean as in menu or the name of the name of the output. So that is in filling a polygon using scanline algorithm. So then it is in glut display function. Thus glut display function is to display the output. Then we call the my init function and the main loop. So with this you can see the output. So for output, run the program, program, so we just having the compilation, that is GCC, so hyphen GLU LGLU hyphen LGLU glut scan file, so .c. This is the output function, I mean output command, which we are going to use to run the program. If no errors, it will alarm set will execute. So this is the output of the given program.